Thank you very much. Thank you. Hopefully I'll be quick, 7 minutes. And it's what I'm going to talk about is more US based. It's kind of a follow-up from my colleague, Dr. Bhargava Reddy, who talked about what we were doing internationally. We basically took a lot of the international evidence and used it for our US based evidence. This is a quick video showing a PAC system. This is Sectra PACs. And this is kind of what we put on radiologist workstations. It's a small widget. And if the if the AI finds a nodule on an X-ray, we can actually show it to them. And if they agree, they can actually add it to the IPN program. We have a CT product as well. And that CT product is now being installed at some very, very prominent centers. The X-ray product is also live. I'm going to show you some evidence there. And then we have an LLM-based tracking program, which is being installed at the largest lung cancer screening program in the country and several other places. So this has been a good year for Cure. There's a lot of problems with X-ray reporting. So Rowena told you a lot of the problems with detecting nodules, but today in 2025, radiologists have a mentality when they approach X-ray. First of all, they know the value of it financially is very low. The intellectual value is extremely low. It's a painful reporting workflow. When I was in training 20 plus years ago, we had alternators, we had multiple X-rays, they were hung for us. We dictated a story into the transcriptionist, and it was very easy. Now it's actually pretty difficult to tell any kind of story because you're only looking at one day and you're just trying to look for change. And we are prone to errors because we're reading very, very fast. We're not even sure if anybody's reading our reports. And then younger rads, every year an attending radiologist gets younger, right? They're not well trained. I had 10 months of X-ray in my residency, and these young rads don't have any of this. It still makes up 51% of the volume that we're reading, and it's still the #1 cause of malpractice when you're talking about the chest. Even in the days of PE studies and dissection studies, it's still very, very common. This is a kind of case that we see. You can barely see this as a stage 1 lung cancer. So we did a multi-center study to get our FDA approval. And what we found is that with AI, there was 50% reduction basically in missed nodules. We also found that the sensitivity of readers who were looking for nodules was going to go up at least about 10%. For whether you're talking about small nodules, which are typically 10 to 20 millimeters in size, or larger nodules, which are larger than 20 millimeters in size, 20 to 30. So our AI can detect from 6 millimeters to 30 millimeters. The rationale is going to be, oh, you must be flooding the systems with granulomas and nipple shadows and rounded atelectasis and all these things. By the way, we did a corollary retrospective study with MGH. These are all thoracic Harvard radiologists, and all the nodules they were missing, we ran them through our AI, and we found 96% of them. And they were nodules that were significant enough to have an addendum placed in the first place. So we know that our AI is very, very, very good and very different than what's happened previously. So Dr. Gupta, who's the chief of cardiothoracic imaging at Cleveland, he is our first site. We now have data from 3 other sites, including MedStar. But the data is kind of very, very consistent. So the first thing we do when we put the AI in is we do a few weeks of retrospective learning. So we can tune the algorithm on the AUC curve. That's actually how we prevent finding too many cases of histo or cocci, et cetera. And then we basically processed about 70,000 X-rays at Cleveland retrospectively, and we flagged almost 1,200 nodules as high risk, and we were finding basically a positive predictive value of 81%. That's really good. It means that we're not flooding the system with false positives. And so what they are doing at Cleveland is they're turning AI on one day, and they're turning AI off one day. All the radiologists are blinded, and there's one adjudicator who's looking for, if the AI says there's nodules, is there really a nodule? And all I really want to show you here is that about 34 of 65 discordances, 34 were true missed nodules by radiologists. So, we are missing nodules. And yet, if you look at the numbers, out of 3,700 chest x-rays, we flagged only 173. So we were not flooding the system. Of that, after you account for NLP errors and everything else, it was about 65 true discordances. So far, we have 4 nodules confirmed on CT, and we haven't even done CTs on all these patients yet. The enhanced detection rate, radiologists are starting to use a term called enhanced detection rate. The first AI that came into radiology was for head bleeds and finding PEs. That had an enhanced detection rate of only 5%, and yet that was viewed to be very, very important, very clinically significant, and very useful for radiologists. This has an enhanced detection rate of 31.5%. So obviously much better. This is one of the cases that we saw. This was radiologists, of course, didn't see that behind the heart. AI did. This is a better case. I never thought I'd see one behind a EKG lead, but this is 19 months later. There's a huge mass. Of course, it's silly to show, of course, AI is going to find some cases like this. It can't be generalized to every case. You got to look at how many false positives are you doing? Are you annoying radiologists with AI going off? We've definitely designed a workflow that doesn't annoy radiologists, but these wow cases, they do matter. They do stick in our brains as radiologists, because if the more wow cases you have, the less annoyed a radiologist will be by a false positive. We just don't have time to, be flooded by false positives. So that's all I wanted to tell you. Thank you so much.